Okay guys, here's another problem from section 4.1 to find the inverse of a function. So I did 64 I believe in the last video. So let me do the next one. The student asking for number 68. So we're given f of x, this is number 68, and our function f of x happened to be 4 over x. And by the way, you notice that there is an extra condition written here, that x is different from 0. Now this condition is of course here, and I'm sure you know why, because this function makes only sense when the x is not 0, because if x were to be 0, obviously you'll be dividing by 0, and you know in math you can't divide by 0, okay? Now you don't do anything with that condition, of course, as far as finding the inverse is concerned, but that's just there to make sure this function is well defined. It makes sense for all values of x, and it does, except for x equals to 0, okay? So you remember the 4 steps we have to go through to find the inverse of any function. Step number 1, I guess I'll go ahead and number them again, but you don't really need to number them yourself. You can just apply them. Step 1 says, remember to change f of x to y. Step 2 says to interchange x and y, so the y is going to become x, and the x is going to become y. And of course, step 3 says to solve for y, so you can see you have a y in the denominator. And of course, to solve for y means y has to come upstairs, up here, or that side. It can't be in the bottom. So the first step is to remove the y from the bottom. So what we'll do, of course, we'll take the same equation and then try to remove the y from the bottom. And of course, to remove any denominator, you're going to do multiplication. Opposite of division is always multiplication. So we multiply both sides by y. So that y cancels that y. So what you're left with, I'm going to move it over here. What you're left with would be, of course, again, this is continuation of a step 3. Yx on the left-hand side, y times x. And on the right-hand side, you're just left with 4 because the y is canceled. And your last step to solve for y, well, to get the y by itself, you have to remove the factor x next to it. Again, opposite of multiplication is division, so we'll divide both sides by that factor x, and they cancel each other. So all you're left with, of course, is y equals to 4 over x. And don't forget, this completes step 3, which of course we found the y, or we solved for y. Now step 4 says to make sure you change y to f inverse of x. Okay, I think I have enough room to show step 4. So we're just going to change y to f inverse of x, which happened to be 4 over x. And also don't forget to, in this case, say x cannot be 0. For the same reason, because again, x shows up in the denominator in your inverse function, or f inverse of x, and of course you can never divide by 0. But this is your inverse for our function f of x, which is 4x. So one thing you do notice, and this is just merely basically, I mean, I don't want to say it's coincidence, but there are special functions where actually they happen to be their own inverses. So what happened here doesn't mean you made a mistake and you're not in twilight zone. It's just that this function, because of its definition, it happened to actually be in its own inverse. And one way to look at it, of course, is, you know, the inverse is supposed to undo what the function does. So if you divide 4 by a number to get back to the original number, of course, you have to basically take 4 and divide it by that, because it reciprocates it. So anyway, just make sure that just because you have the same answer, the function and the inverse are the same, doesn't mean you did something wrong. This doesn't happen too often, but for certain function this can happen, okay? All right, I'm going to go ahead and stop this video, so because I don't want to put too much in each video, so hopefully it'll be easier to upload them, okay? So I'll do one more problem, and that should be the 3 questions that was asked about section 4.1. But let me know, guys, if you have more questions.